Good day, everyone. After we have looked through the roadmap for electric current, now we're going to study the questions in past year, which happened in the year 2015. So we are provided with the potential difference, the length of the wire, cross-sectional area, current, and also the mean free time between the collisions of free electron with atoms. So the first question here is about the electrical conductivity of the wire. So from here, we are provided with the voltage and the current. The first thing that I can think is we can find the resistance of the wire. So we have learned about the resistivity is the reciprocal of the conductivity. First, we have the formula of the conductivity is the reciprocal of resistivity. And we also learned that the resistivity is the RA over the length. And here we can have the expression of the conductivity equal to the current multiply the length divided by the voltage and the cross-sectional area of the wire. So when you put in all the value, so you should have get the answer of 3.5 and multiply 10 to the power 5 Siemens per meter. And then we could have another way to solve these questions where we learn about the Ohm's law, which we have proved its equivalence with the equations of J equal to sigma E. So we can calculate the current density using the I over A, whereas the electric field strength E is the ratio of the potential difference and the length of conductor. So here we have the conductivity equal to the current multiplied the length divided by the cross-sectional area and the potential difference, where you will also get the same answer as the previous solutions. Next, we are going to find out the electron density in the wire, also known as the free electron per volume. We have the value of the conductivity. So we learned that another formula for the conductivity is the Ne square T over M, where the value for each of the terms except the electron density are given. So we rearrange the equations where the electron density is the sigma M divided by E square T. So you put in all the value and you could get the answer of 7.16 multiplied 10 to the power 27 per meter cube. Regarding the electron density, there is another related formula which is the I equal to the net. However, the drift velocity is not given, so we need to find out the value of the drift velocity, which will be discussed in the next questions. So now we're going to discuss the third questions, which is the drift velocity. To find out the drift velocity, so we can refer to the mechanism of electric conduction that I've discussed in the roadmap, that when there is potential difference across the metal wire, we have the electric field set up in the wire that exert electrostatic force on electron and cause the electron to accelerate. As on this scenario, we have derived the drift velocity as EET over M before, and we could substitute the E as the voltage divided by the length of the wire. So here we substitute all the value where the electron charge multiply the voltage and the time between collision divided by the mass of electron and the length of the wire, and you could get the value of 2.6 multiplied 10 to the power of negative 3 meter per second. Another solution to determine the drift speed of the free electron, we can use the equations of I equal to NAV when the electron density is determined. So we can calculate the V as I over NAE. You put in all the value, and you could also get the same answer as the previous solutions. So we have discussed almost all the formula mentioned in my roadmap video. There's one more thing that's not mentioned is about the time of the current flow. So we're going to look at another questions in past year, which is also 2015, where the question gives us the information about the length and diameter of the wire, potential difference, and the time of current flow, which is 150 seconds. The resistivity of copper and the electron density are also given. Also, we are given with the diameter of the wire, where we could calculate the cross-sectional area of the wire as pi d squared over 4. Or you can use also the formula of pi r squared. So the cross-sectional area would be 4.34 multiplied 10 to the power of negative 6 meters squared. Now, the first thing we're going to look is the current in the copper. So since the resistivity, the length, and the area are given, so we can calculate the resistance, and we can use the equations of V equal to IR to determine the current in the copper. So here we can express the current as the potential difference multiplied the cross-sectional area divided by the resistivity and the length of the wire. You put in all the value and you get the answer as 16.78 ampere. Now we are going to discuss how we can use the time of the current flow. So the first thing that we can find out is the total number of electrons per second, where we have the formula of I equal to NE. So the number of electrons per second can be determined using the expression of the current divided by the charge of electron. And you could get the answer of 1.05 multiplied 10 to the power of 20 per second. Another thing that you can find out is the total number of electron, where you have the equations of I equal to number of electron multiplied the charge of the electron divided by the time of current flow. So we could express the total number of electron as the IT over E, or equal to NT, and you could get the answer of 1.57 multiplied 10 to the power of 22 electrons. So that's conclude my discussion for today. I've covered almost all the formula and the terms in this chapter. So if you have any questions, you can leave in the comment section. Also, do leave a like and subscribe my channel. I'll see you in my next video. Thank you.